Okay, in this chapter we're going to talk about how to do statistical analysis with more than two groups. In the previous chapter we talked about t-tests. T-tests are of two different kinds. There are independent t-tests and dependent t-tests. T-tests are used to compare two groups and only two groups. Sometimes we can do one-tailed tests. Sometimes we can do two-tailed tests. If we're not sure where the differences are between the two groups, we do a two-tailed test. If we're making a hypothesis that one group is larger or better than the other, then that is a one-tailed test. Just to reiterate, we cannot do multiple t-tests. We can only do one t-test for you can use multiple variables, but you can only compare two groups. So just as an example, let's say that I wanted to determine whether or not having thumbs when you're trying to tie a bow was important. I could divide into two groups, have a group with thumbs, their thumbs were free, and a group without their thumbs, meaning that their thumbs were tied to their hands, and ask them, how long does it take you to tie a bow on your shoe? So we can collect average times for all these participants and have another group, or actually it could be the same group, and collect time where they can use their thumbs. Results indicate that those without thumbs took much longer than those with thumbs. So that's just a brief example of a t-test. Now, consider this. Let's say that I want to compare freshmen and sophomores in regard to the PSAT scores. I could do that with the t-test as well. But what if I want to compare all the kids in a high school? What if I want to compare the freshmen to the juniors, to the sophomores, to the seniors? I can't do that with the t-test, because every time you run a t-test, when you compare the freshmen to the sophomores, you have a little bit of error in that. When you compare the sophomores to the juniors, you have a little bit of error in that. We don't want to keep doing that over and over. So we have another test called an ANOVA. An ANOVA is used for a specific purpose. So for example, let's say I've got freshmen, sophomores, juniors, and seniors, and I want to know if there's a significant difference somewhere in these groups. One way ANOVA is used with one independent variable, and that's the variable that we can control or manipulate or allow to be different. So in this example, that would be the PSAT scores. The dependent variable is the value that may be determined by the independent variable. So I want to know if there's a difference in the PSAT scores based upon what classification the students are at. In other words, does being older have a different impact on the PSAT scores the students get? So the analysis is run, and I end up with an ANOVA. ANOVA tables look something like this. What we're looking for is, obviously we have differences within groups. Not every freshman got the same score. That's why we have a mean. So there's difference within groups. And there's also a difference between groups. A freshman's probably not going to get the same score as a sophomore. And what we want to know is that if the difference within a group, is it larger than the difference between the groups? This is an ANOVA table from a different study. One of the things that you'll notice is we do have degrees of freedom. Between the groups means exactly what it says, how many groups we have. This works exactly the same way as the t-test did, in terms of you add one back to determine how many groups we have. So for example, here we have 7 groups. Again, the degrees of freedom, we take one away from each group. So if we had 7 groups and we took one away from each one, that'd be 1,438 people. This score is called an F score. But really what we're looking for is to determine whether or not this number is less than 0.05. Again, it is possible that there is some difference in scores within each group, and we can assume that it's highly unlikely that every person got the exact same score. But what we're looking for is differences between groups. And it's the ratio between those two values that we're trying to determine whether or not there's a significant difference, that is, a p-value that is usable. So our null hypothesis would be, in this example, that the PSAT scores of the freshmen are equal to the PSAT scores of the sophomores, are equal to the juniors, are equal to the seniors. And we briefly kind of hit on this already, but basically what we want to know is where the differences are. Again, here's the variance within a group, and these numbers really don't mean anything right now. The differences between the groups, how many groups we have, how many participants we have, the F score, just like we got a T score with the t-test, and a significance level. What I'm trying to figure out is whether or not there's a difference between the 4 groups. I have freshmen, sophomores, juniors, and seniors. What I'm trying to figure out is if there is a significant difference between the freshmen, the sophomores, juniors, and seniors. And that's all I can do right now is figure out if there is a difference. Another way that you'll come across the description of these is like this, where it's written out in more like a sentence instead of a table. Again, here's the degrees of freedom between the groups, within the groups, the F scores, and the p-values, just like that. So if you look at the example that I gave you in this table, you can determine where these scores came from and how these correspond to this. Now, we're going to look at an example of this, and the first one I'm going to show you, and then the other one I'm going to turn into a discussion thread. This is a data table from an article called Teaching Strategies. What they're trying to determine is if there's a significant difference. One of the things they're trying to do is determine if there's a significant difference in the methods used to manage ADHD behaviors in the classroom by age classification. So, for example, teachers 30 and under, 31 to 40, 41 to 50, and teachers that are over 50. This is their score. This is how many they had. Standard deviation. Now, what we can determine is we have between groups and within groups. We have degrees of freedom. We know we had 4 groups, so we have 3 degrees of freedom here, and these probably add up to 225. So we can determine that, based on the analysis of variance, that there is a significant difference between these 4 groups. What we don't know is where the significant difference is. Here's a written description of where they were talking about the same thing, the significance level that they determined. So if we scroll on down, now we want to know if there's a difference in terms of years of experience and the methods used to manage ADHD behaviors. So now we have 5 groups, there's 4 degrees of freedom. And based upon the scores that are provided, it appears that there's not a significant difference in terms of number of years of experience because this value is greater than 0.05. Again, going back up to the top as opposed to here where the value is less than 0.05. So you'll have a discussion thread based upon the geography paper that we used in t-tests, and we'll just briefly go through it, and there's just about 4 questions that are associated with the ANOVA. We just discussed previously we don't use multiple t-tests because every time we use a t-test it creates error. Well, this can happen with running multiple ANOVAs as well, but there's an adjustment that can be made for that, and it's something that you'll probably come across called a Bonferroni adjustment procedure. And what they're doing is they are forcing the significance level up statistically to make sure that there isn't a mistake that's made, that you're not seeing a difference where there's not one, which is, if you remember, called a type 1 error, a false positive error. Now, just to sum up, the differences between t-tests and ANOVAs is t-tests are used to compare 2 groups. ANOVAs are used to do multiple groups. One of the advantages of a t-test is if you determine there's a difference because there's only 2 groups, then you know which group is larger than the other one. So if you have a set of scores for one group that's higher than the other, and it's a t-test, you know that that the significant difference is going to be less than 0.05. The problem with an ANOVA is if we look at this, where we have mu1 equals mu2 equals mu3, then if we ran an ANOVA on that, it said that there is a significant difference between those. What we don't know is where the significant difference is. Going back to the teaching strategy example, we found a significant difference in terms of how old the teachers were and the strategies that they used, but what we don't know is where the difference is. Just because the numbers are different doesn't mean there's a difference between each of the groups. To determine that, we use something called a post hoc test, which is what is under Chapter 12.